2.2 Intercepts, Symmetry. So intercepts, something you already know about. Symmetry, that's something new. We haven't really talked about anything new yet. This is going to be the first thing that's super duper new. Alright, let's talk about intercepts though. To find the intercepts of an equation, to find the x-intercept, you make y equals 0, solve, you're going to have number 0. To find the y-intercept, you make x equals 0, solve, you're going to have the 0 number. When you get stuck in college algebra, always think of the opposite. If we're finding intercepts, something needs to be 0. The opposite of x is y. That's why y is 0. For a y-intercept, the opposite of y is x. That's why x is 0. Guess what? This is the only way from an equation right now that most of us will probably learn. This is the only way to find intercepts. So if you need to find intercepts of anything, make the opposite 0 if the domain supports it. We're going to learn more about that when we get to chapter 3. First, let's just practice finding intercepts. Let's find the intercept of the graph y equals x squared minus 4. So we have two types of intercepts possibly, x and y. Alright, to find the x-intercept, we make y equals 0 and solve. To find the y-intercept, we make x equals 0 and solve. Alright, let's find our x-intercept. So we make y equals 0. So we have 0 equals x squared minus 4. We add 4 to both sides. We get 4 equals x squared. We square root. So we get plus or minus 2 equals x. So we have negative 2, 0, and 2, 0. The reason why we can just say make y 0, make x 0, and why we're just allowed to do that, because an intercept falls on x or y being 0. An intercept is where it perfectly is on one of the axes, either the x or the y. So if it's an intercept, we know for sure one of the numbers is always going to be 0. That's why we're allowed to say make it 0 and solve, because we know that's where it's always going to exist because it's an intercept. Let's find our y-intercept. So for our y-intercept, we have y equals blank squared minus 4, and in that blank, we're plugging in 0. So we get y equals negative 4. That means our y-intercept is 0, negative 4. Symmetry. So a graph is said to be symmetric with respect to the x-axis if for every point xy on the graph, x negative y is also on the graph. So if we pay attention to xy, x negative y, do you notice that the y is what changes? You want to know why? Because this is symmetry to the x-axis. What's the opposite of x? Y. So when you need to find symmetry, you need to make something negative. And we can do that for a very similar reason as we can just make x and y equal 0, because those are rules. We know that this is where it exists. Same thing with symmetry, that if you have a graph with these two types of points, we know what type of symmetry it is. So hypothetically, if we had this point here, and that was 4, 1, that means the symmetric point would be 4, negative 1. The only thing that switches is your y. So for x-axis symmetry, y becomes negative y. X stays the same. Alright, let's talk about symmetric with respect to the y-axis. What do you think, now Dora the Explorer this, what do you think is going to be switched if it's symmetric to the y-axis? X. You're right, X. Really is Dora the Explorer up in here. Alright, so it's symmetric with respect to the y-axis for every point xy on the graph. The point negative xy is also on the graph. So this time, because it's symmetric to the y-axis, the only thing that switches is x. So let's say I had this point right there. Let's say that is negative 3, 5. That means the symmetric point to that would be positive 3, 5. So for y-axis symmetry, x becomes negative x. The last type of symmetry for college algebra is origin symmetry. So a graph is said to be symmetric with respect to the origin for every point x, y on the graph. The point negative x, negative y is also on the graph. So this one, there is no remembering, there's no special thing, it's just both. Origin is both. The reason being because origin, you fold it diagonally over. So that's why both points are being switched. With your piece of paper, fold each of these graphs over the axis and you'll see how they go on top of each other. So for origin, there is no trick. You're just switching both. So if we had this point right here, let's say that was -2, -5. That means this point right here would be +2, +5. So you just switch the points. So for origin symmetry, x turns to negative x and y turns to negative y. You do both. Guess what? That's actually how you find it algebraically as well. We just came up with the rules based off of the picture. That's what this blue text is about. So you actually together, we all came up with the rules on how do we find symmetry. So to test an equation for symmetry, so without graphing, if you want to find x-axis, you replace y by negative y in the equation and simplify. If an equivalent equation results, the graph of the equation is symmetric with respect to the x-axis. For the y-axis, you replace x by negative x, simplify. If it results in something similar or the same equation, it's symmetric. Origin, replace x by negative x, y by negative y in the equation and simplify. If the equivalent equation results, the graph is symmetric with respect to the origin. You have to do all three. The reason being, a graph can be symmetric with respect to the origin, x, and y-axis. How? Are you trying to picture a graph that's symmetric to everything? Well, guess what? That's 2.4. That's when we start to graph stuff like that. But let me show you a graph that's symmetric to all three. A circle. If you fold it over here, it goes on top of each other. That's y-axis. If you fold it down over the x-axis, it goes on top of each other. If you fold it over the origin, it goes on top of each other. So a circle is actually symmetric to all three. So that's why you have to test all three. It could be x, y, and origin. It could be two of them. It could be one of them. Or it cannot be symmetric at all. Symmetry is so important in math because of nature. Nature is all symmetrical. So if we're symmetrical. Take, like, in the morning or whenever you're in bed or just bored, look up a 5-minute video about the golden ratio. It will blow your mind, and then that will lead you to fractals, and that's even more mind-blowing. So symmetry is so important because of nature. That's why we need to start learning it. You're really going to dive into symmetry when you get into calculus. Alright, so let's test all three. Let's test for symmetry of y equals 4x squared over x squared plus 1. Yeah, a fraction. I know, I'm not even starting off easy with y'all. I'm jumping in right into a fraction, because I know you can do it. Alright, let's talk about x-axis. And then we have to test for the y-axis. And then we got to test for the origin. So what I do is I write all three so I don't forget to do all three. Don't forget, you have to try all three of them and see what happens. So, because of symmetry, how do we remember which one is which? Symmetry, something needs to be negative. The opposite of x is y. So we're going to replace y in the given equation with negative y and simplify. So let's do that. Let's replace it. So we have negative y, and that's going to equal 4x squared over x squared plus 1. Now, what do we mean by simplify? Well, you're never allowed to have negative y equals. It should always be y equals. So we need to get rid of that negative. In order to get rid of it, we multiply both sides or divide. It doesn't matter. It's the same thing. We just multiply by negative 1. When we multiply or divide by a negative 1, this is where I see a lot of people mess up, even in higher classes. So I want to nip this in the butt right now. When you multiply or divide a fraction by negative 1, it can only go to one spot. You only can put the negative to the top, or the bottom, or the middle. And we're actually going to practice with all three so you see what I'm talking about. So if we distributed the negative to the top, remember it only goes to one spot, never top and bottom, just one spot because you're multiplying by negative 1. If we threw it to the top, this is what it would look like. That's what happens if we put it to the top. If we put it to the bottom, this is what it would look like. If we put it in the middle, this is what it would look like. So you have to pick only one of them. Let's go back to the original equation. The original equation is y equals 4x squared over x squared plus 1. So let's see, do we have that in our final versions? For the top, that's negative 4x squared. So no, that's not the same. It's not the same as what was given. If we look at the bottom, that's not the same because there's not supposed to be a negative there. It's not the original equation, so it's not the same. If we look at the middle, that's also not the same. And we're comparing it to the original equation they gave us. We're comparing it to this one right here. After you simplify with top or bottom or middle, one of them needs to match. At least one. None of them match. Since none of them match, it's not symmetrical to the x-axis. So it's not. We just keep going with our lives. Yes, all of that work just to say no. Alright, let's do our y-axis. So since we're talking about symmetry, we know that something needs to be negative. So the opposite of y is x. So x needs to be replaced by negative x, and then we simplify. So in the given equation, y equals 4x squared over x squared plus 1, we're going to replace x by negative x. So we have y equals blank squared, and then we have blank squared plus 1. And in that blank, we're plugging in negative x. And let's simplify because we can. Negative x squared is actually positive x squared. If we look, that is the same exact thing from what we started with. They are identical. So since it's identical to the given equation, we say it's symmetrical because that's not our final answer yet because it could be origin as well. We have to check the origin. So we just move on. Let's do origin. So origin is the special one. We do both. Now, this is a interesting way and a funny way on how I remember that it's both. Origin has two eyes, so I need to do two things. Does that works for me? Just start using devices and phrases and funny little things to help you figure out how to remember everything. But with origin, we switch x to negative x and y to negative y, then we simplify. So basically, we just kind of do both steps into one. So let's do that. We have negative y equals, I just realized I forgot to put the 4 on the y-axis. It's okay, we still got the right answer. It's still the same thing. I forgot to put the 4, so I plugged in the 4 right here and right here. That's okay, it didn't mess us up. Let's do our origin. Alright, then we have 4 blank squared over blank squared plus 1, and in that blank we're plugging in negative x. So we always do the x's then the y's. That's the rule. Why? Because it's in alphabetical order. Also, x matters way more than y. So we have negative y equals 4 positive x squared over positive x squared plus 1. Now, I don't know if you notice, we already did this. I'm going to circle it in green. Doesn't this look exactly like this? It's the same exact thing. And when we did that, it didn't work. Work smarter, not harder. You do not have to repeat the steps again because we already did this part. We already did negative y equals 4x squared over x squared plus 1. It didn't work. So it is not going to work. Since it's not the same, the only thing it does work with is the y-axis. So how we write our answer? If it was symmetrical to many, you just say y-axis, comma, blah, blah, blah. We will have an example of if it's symmetrical more to one, don't you worry. If you feel like you can, pause and try example 3. If you don't feel like you can, that's okay. Let's keep going. Let's test y equals x cubed for symmetry. So, as you notice, I started off really hard with a fraction. Why? Because it makes you appreciate example 3 a lot more. Jump in. Why not jump in? Don't tiptoe. Just jump in, right? Whenever you go to the springs, isn't it easier just to jump in the cold water than to tiptoe in the cold water? Same thing. We're jumping in with math. So we have to test all 3. Why? Because it could be all 3. It could be 2 of them. It could be none of them. So we have to try our x-axis, our y-axis, and our origin. And we test them because now you see sometimes it works, sometimes it doesn't. That's why we test for symmetry. We're seeing, does it follow the same guidelines that we want it to? So how do I remember? Symmetry means something needs to be negative. So x, the opposite of x is y. So y needs to go to negative y, and then we simplify. So we have negative y equals x cubed. We're not allowed to have negative y. This is not a fraction, so we just move it over. We're going to multiply or divide by negative 1. And when we do, we have y equals negative x cubed. That is not the same. Since it's not the same, we move on with our lives and go to the y-axis. Okay, for the y-axis, something needs to be negative for symmetry. What's the opposite of y? X. So x needs to be negative. So let's do that. We have y equals blank cubed, and in that blank we're plugging in negative x. Don't forget, this is technically negative x times negative x times negative x. So we're actually left with negative x cubed. That's not the same either. Alright, let's move on to our origin. If you're doing your homework or the review and you're like, I'm starting to pick up on patterns, when I look at this after you do your homework and stuff like that, you're going to start realizing I think I know what that is before I even do the example. Great, that's awesome, because these are patterns. Symmetry is patterns. So that's why you're starting to pick up on patterns as you do your homework. But you still have to show your work for all three. All right, so for origin, we do both. So we have negative y equals negative x cubed. All right, always x first. So we have negative y equals negative x cubed. Remember, we already did this. We already did that part. And then negative y equals negative x cubed, we have not done that. There's no example here yet on x-axis or y-axis that matches that. So we just keep going. We multiply or divide by negative 1 to get y by itself. And when we do, we have y equals now positive x cubed. Oh, that's the same. It worked. So it's actually only symmetric with respect to the origin. Every single example we've gone over in this section, we're actually going to learn to graph them as the semester goes on. So we'll learn to graph something like that in Chapter 5, and the same thing here. We're going to learn to graph that in Chapter 5. So you're going to see how that even could be symmetric to the origin in Chapter 5. Alright, so we're going to do the same thing. Given the equation, test for symmetry, then we're going to find intercepts. So let's go ahead and do symmetry. Now, if you didn't try it last time, I really want you to try. Pause the video and try. Okay, I hope you did. Remember, you're the only one that knows if you get it right or wrong. So no one else is there but you. Try. If you get it wrong, it's okay. If you get it right, awesome. Alright, let's test all three. We have x-axis, y-axis, and origin. Alright, we have 4x squared plus 9y squared equals 36. Alright, so let's do our x-axis. Remember, we're going to switch y to negative y and simplify. So we have 4x squared plus 9 blank squared equals 36. And in that blank, we plug in negative y. So we have 4x squared plus 9 negative y squared is positive y squared equals 36. Oh, hey, that's the same thing. Sweet. Let's keep going. Let's do our y-axis. So for y-axis, we switch x to negative x. So we have 4 blank squared plus 9y squared equals 36. And in that blank, we're plugging in negative x. So negative x squared, that's positive x squared. So we have 4 positive x squared plus 9y squared equals 36. Oh my gosh, it worked again. Do you think it's going to work for the origin? It is. It's going to work for the origin. Let's prove it, though. So remember, origin, we do both. All right, let's do that. So we have 4 blank squared plus 9 blank squared equals 36. And in our first blank, we're plugging in negative x. And our second blank, we plug in negative y. We know when we square a negative, it's always positive. So we have positive 4x squared plus positive 9y squared equals 36. And oh my gosh, that's the same. It's symmetric to all three. You want to know why? Because this is a circle. Circles are positive x squared plus positive y squared. They're always going to be positive squares for x and y. So if you have a squared variable, the opposite of that variable, it's going to work for your symmetry. Do you notice x is squared? That's why y-axis worked. Y is squared? That's why x-axis worked. If you have two xy squares, it will always work for the origin. So how we say that? We just say symmetric with respect to all three. Alright, now let's practice finding intercepts again. So there's only two types, x and y. And I know there's only two types because we only have two variables. If you had xyz, you could possibly have 3. If you had wxyz, you could possibly have 4. Alright, so for the x-axis, or x-intercept, we know that y is going to be 0. Remember, for intercepts, something needs to be 0. Opposite of x is y. So we have 4x squared plus 9 blank squared equals 36. And in that blank, we're plugging in 0. So 4x squared, that goes away, equals 36. Divide by 4. We get x squared equals 9. We square root 9, and we get positive negative 3. So we have negative 3, 0, and 3, 0. All right, let's do our y-intercept. Intercept, something needs to be 0. The opposite of y is x, so x needs to be 0. So we have 4 blank squared plus 9y squared equals 36. And in that blank, we're plugging in 0. So that goes away because it's times 0. So we're left with 9y squared equals 36. Divide by 9. We get y squared equals 4. Square root it. And we get y equals positive negative 2. So we have 0, negative 2, and 0, 2.